but we rely on this heavily, this idea to do the rest of this course. We need this condition. We need to be working with functions that are continuous for us to be able to do some stuff. I also want to point out that if you go between A and C here, right? Look at this. All these values in here must be positive, right? So like if I pick any value between A and C here, that they should all be positive. And then if I pick any value over here, it should be negative, shouldn't it? Okay. You'll see this, hopefully I can paint the full picture for you when we bring this all together next class. Now I'm not done, but that's where we're going to end this section. And I'm going to introduce you to the derivative, 10.4, the next section, and then we'll get into it heavily next time. You know what? I can do something that might help you see what I'm getting at here. See if this looks familiar to you from the last class you had, 1324. In 1324, you would graph something, and then like a parabola, and you'd be told that this is your profit function, right? And it would be some quadratic, right? And then you were asked to find the break-even points. So when you found the break-even points, you found your x-intercepts. Okay? And then you were told to explain where your profit is positive, right? Where is your profit positive? And so what you would do is you'd say, hey, between here and here, my profit is above the x-axis, so I have positive profit in here, don't you? Now, why is it that you knew, without even graphing it, how is it that you knew that this thing didn't do this and come back down and then go like that? How did you know that you weren't going to have negative profit in here? Well, what you were relying on was the idea that this function was continuous. And if it's continuous, and these are the only two x-intercepts you found, then it's impossible for it to do something crazy in between these. It can't do anything because it's continuous. Does that make sense? It can't just like start up here and then all of a sudden show up down here and then go and then jump back up here. There's no breaks in it. So we've seen this in the past, but we're going to really need it more now. All right, let's talk derivative. If you go ask any business calculus student, 1325 student, or any 2413 calculus 1 student, what is calculus about? They will tell you it's about the derivative. That's what they'll tell you. Okay, so that's why I had put a little star on it when we started class, because this is probably the fundamental idea behind this class. So 10.4, the derivative. And like I've done in the past, I'm going to try and motivate this visually first. And we've actually talked about this already. If we have a graph of a function, and let's call this function f, and let's say it's continuous everywhere. So there's my function. Do you remember me talking about trying to find that tangent line, that line that would be like this? You remember me talking about that? You remember what I said we were going to have to do that? I would have to start out with picking a point somewhere else, right? And then slowly sliding that point over and bringing it right on top of that one. And we said when we did that, it was going to create a problem, an issue, that we were going to get 0 over 0, right? Okay, so let me see. Are they using A? Yeah, they're using A. So let's say that we've got this function, and I want to pick a point somewhere over here. Then I'm going to call that point something different. But I'm not going to call it B. B would seem pretty natural, right? If that's A, we'll call this B, yeah? We're not going to call it B. We're going to call it A plus H. So it's this number plus something. I'll give you an example of that. If I say like this was 3, then this could be like 3 plus 1, which would be 4, right? So it would be to the right of it. Make sense? So this is just whatever this number is plus something. All right? Let's connect these with a straight line. And I would like for us right now to look at that blue line, and I'd like for us to find its slope. What is the slope of this, what we call secant line? What is the slope of that line? So you were taught slopes of lines in 1324's rise over run, yes? Rise over run. And another definition of slope was, and I'm going to put M with SEC below it so that you understand I'm talking about the slope of the secant line right now, that line right there. This slope, rise over run. But another formula was y2 minus y1 over x2 minus x1, right? That was it? Okay, let's actually figure out what these points are. So A is the x-coordinate, right? What is the y-coordinate of this point? F of A. Good. It's F of A. That's how tall it is, right? You plug in A, it spits out the function's value at A, right? So written as an ordered pair, this is the point A, F of A. Go with me on that? A, F of A. Yes? No? Yes. Yes? Okay. What about this point right here? What are its coordinates? So what am I plugging in? A plus H goes in. And then what is the function's value there? Well, it's whatever I get when I plug A plus H into the function, right? It's whatever I get when I plug A plus H into the function. I don't know what it is, but that's what the value will be. So written as an ordered pair, it's A plus H, and then the function's value at A plus H. So what is y2 minus y1? What's y2? Is this one right here? That's y2. This is x2. This is x1. This is y1. So y2 minus y1 would be f of a plus h minus f of a all over what? It's a plus h minus a. It's this one, a plus h minus a. Now we can clean that up just a little bit. F of a plus h minus f of a, all divided by, notice that these a's cancel, and you just get h down here. Now this should look familiar. You recognize that? You should have seen that in 1324. We call this the difference quotient. That sound familiar? Difference quotient? We need one more thing to start doing calculus with it, but that should look familiar as the difference quotient. You may have had f of x plus h minus f of x, but I'm using a because that's what the book's using right now. Okay, any questions as to where this formula came from? So using this formula, if somebody gave me if somebody gave me a value for a and h, and I plug them in, and I'd compute this, right? And that would give me the slope of this blue line. Agreed? But that's not what we want. We want to move this point over here, right? I want to move this point so that it gets closer and closer to this one. So if I anchor this, let me anchor this thing here, and I slide my point where my fingers are along the curve, I'm trying to get that point right on top, and see I'm starting to get to some line, and that right there is called the tangent line. Understand? Tell me how I can slide this point over. What do I need to do to slide this point over? Look at it in terms of the 3 here. What could I do to make this point right here get closer to 3? I could, well, just make h smaller, right? Think about it that way. If h is 1 here, what if h was 0.5? Wouldn't that move it like right here? What if h was 0.1? H, if that number gets smaller, right? If this number gets smaller, doesn't this get closer to 3? So I need to let h get smaller, smaller, smaller? How small?
Close enough to A. Not A, but close.
I want this number right here, where do I want it to go to? 0, right? If I make, see the thing is if I make it 0, this is just 3 and 3 and they're in the same place, right? So why don't we bring in the limit then? Because we can't let it be 0. If we let it be 0, they're on top of each other. But I can ask myself what happens as h goes to 0, right? So this right here gives us the slope of the secant line. But if I want to know the slope of the tangent line, tangent, that's our goal, okay? The only thing I need to do is let h go to 0, right? That's it? So I'm going to rewrite this formula, but in front of it, I'm going to write the limit as h goes to 0 of this. Another way of saying this is that all this difference quotient stuff you did in 1324 was just to get you ready algebraically to do one more step in this class. And that new step is that we're going to take this, and at the end of our computation, we're going to let h go to 0. It's going to be a limit. All right? I think that's a good place to stop. What we'll do next class is I will start with this on the board, and we will start working examples, and we are going to try and find slopes of tangent lines. Yes? Yeah, I didn't pass it around. You know what? Who's not here? I wish I could just do it that way. Let me see here. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8, 9, 20, 3. Okay, so I'll do it fast. I'll do it fast. You just say here, you can go. Georgette, here. Monica, here. Nathan, here. Jacob, here. Quentin, here. Zara, here. Alea? Here. Okay, I think I messed it up. Emmanuel, I've got you. Emmanuel, yes? Here. Kobe, here. Aaron, here. Pierce, here. Armando, here. Jonathan. Okay, Carlos, Lorenzo, here. Derek, here. Stephen. Okay, Alexander, here. Michael, here. Junior, here. Nicholas, here. Ebony is here, Miguel, here. Matthew, here. Sydney. Okay, miss anybody? Y'all have a great day. Do your homework. What is the 10-3?
Okay, so that's not little, is it like a